Hey again, guys, it's Mr. Zigner. We're at Chapter 4, Lesson 2, looking at greatest common factors. All right, so we can see here, we're going to go through that main idea, which is GCF, talk about a couple vocab words, then we're going to find the GCF of 2 and then 3 numbers, and then try to use it for solving a word problem. Let's get started. All right, so again, finding the greatest common factor of 2 or more numbers. Yeah, sometimes we'll do 2 numbers, and then sometimes we'll have 3. I don't think we ever try more than 3, so it's always going to be finding the GCF of 2 or 3 numbers. Venn diagram is one of the words we're going to be defining, also greatest common factor. All right, so here's a little walkthrough. This one is a method where we just list all the factors of the numbers. This is actually how I was taught. Ask your parents. This may be how they were taught to do this also. So first you list your factors of 28. Well, you can see right here that those are, from smallest to largest, factors again of a number are numbers that go into evenly 28. So the numbers that go into 28 are 1, 2, 4, 7, 14, and 28. The factors of 42, again, the numbers that can go into 42 evenly, are 1, 2, 3, 6, 7, 14, 21, and 42. Now, what's the greatest one they have in common? Well, you can see they have 1, 2, 7, and 14 in common. They both have those as factors, but the biggest one is, of course, that 14. So there you go. That's one way of finding the GCF. I like this one a little bit better. So you actually do the prime factorization of each number, which is exactly what we did prior to this lesson. So you do your prime factorization of 28. Let's see, what times what is 28? How about 4 times 7? And now 7's prime, we circle that. 4 is 2 times 2, but they're both prime. So we have our prime factorization of 2 times 2 times 7, 42. Let's see, 42 could be 7 times 6. 7 is already prime. 6 is 3 times 2. They're both prime. So my prime factorization for 42 is, in order from smallest to largest, 2 times 3 times 7. So what do they have in common? Well, you can see right here, they both have a 2 as a factor in common, and they both have a 7. So what you do is you multiply those together, and 2 times 7 is 14. So that's a different way of finding the GCF. That's my favorite. I like that a little bit better than listing out every single factor of each number. I hope you like it too, but you can use either method. Okay, it's our turn. We're going to find the GCF of 18 and 45. So let's try that using the prime factorization. For goodness sakes, we practiced that in class. Let's use that now to find the GCF. So let's see, prime factorization of 18. How about 2 times 9? 2 is already prime. 9 would be 3 times 3. Okay, they're both prime. I'm going to circle them. So my prime factorization of 18 is 2 times 3 times 3. All right, so now 45. So let's see, how should I start with 45? How about 9 times 5? Okay, well, 5's prime, but 9 is composite, so I'm going to bring a new set of branches down, and 9 is 3 times 3. There we go. So we're all finished with that one. So in order from smallest to largest would be 3 times 3 times 5. Now let's see if I can move that over right below the other answer. All right, so what do they have in common? Well, let's see. This one has a 2, but that one doesn't have a 2. Oh, here we go. They both have a 3 in common. And that seems to be it. 18 has another oh, wait, no, there it is. They each have another 3. Oh, my bad. How did I miss that? So they each have 2 3s in common. So let's see. They each have 2 3s in common. And now what we do is we multiply those common factors, and 3 times 3 is 9. Now let's check, is 9 the largest number that divides evenly into 18 and 45? Sure is. Moving on. Okay, oh, here we go. Now we're being shown how to find the GCF of 3 numbers. Well, method 1, we're going back to the listing every single factor of each one. So here are all the factors of 21. Here are all the factors of 42. And here are all the factors of 63. It's funny looking at that. That's exactly how I used to do it when I was a kid. What's the biggest one they all have in common? Well, there it is. It's that 21, the largest one they have in common. So the GCF is 21. Again, you're certainly welcome to do it that way. Now here's the same problem, this time using prime factorization. Well, 21, I'm going to not do all the prime factorization each time just to save some time on this video, but we're going to have to trust the book here that 21's prime factorization is 3 times 7. 42's prime factorization is 2 times 3 times 7. And 63's prime factorization is 3 times 3 times 7. So next step is to just to circle those common factors. So they each have a 3, they each have a 7. So you multiply those two numbers together that they have in common, and 3 times 7 is 21. All right, let's give this a try. So now we're finding the GCF of 24, 48, and 60. All right, let's get busy. Well, let's see here. 24, see, that would be 12 times 2. 12 would be, how about 4 times 3? And 4 would be 2 times 2. So we have 2 times 2 times 2 times 3. Okay, now we switch up the colors, and 48. Let's see, how about 24 times 2? And then 24 could be 12 times 2. And 12 could be 6 times 2. And 6 could be 3 times 2. There we go. We're finally finished. So the prime factorization of 48 is 2 times 2 times 2 times 2 times 3. All right. Let's just scoot that down maybe a little bit. All right. Now we have 60. 60 would be, how about 30 times 2? And 30 could be 6 times 5, and 6 could be 2 times 3. And there we go. We have all prime numbers. So we have 2 times 2 times 3 times 5. All right, so let's see what they all have in common. Well, let's see. To start off with, they all have a 2. And it looks like they have another 2. All right. Well, they don't all have a third 2, but they all have a 3. Is there anything else all 3 of them have in common? Doesn't look like it. Nope, that's it. So now we multiply those numbers they have in common together. They all have a 2, they all have a second 2, then they all have a 3. Let's see, 2 times 2 is 4, and 4 times 3 is 12. So there we go. Our GCF is 12. That's the largest number that will divide into 24, 48, and 60. Okay, here we go. Woo, here we go. Long problem. Alice is making candy baskets using chocolate hearts and lollipops. She's tying each piece of candy with either a red piece of string or a green piece of string. She has 64 inches of red string, 56 inches of green string. She wants to cut the pieces of string in equal length and use all the string she has. What is the length of the longest piece of string that can be cut? Oh, do you see what's going on here? So you've got this one string that's 64 inches long, another one that's 56. So really, what's the largest cut that you can make so that you're using the same length on both pieces of string and end up using all the string. So what we need to know is what's the greatest common factor of these two numbers? What's the biggest number that we could cut these pieces of string into so that each string is cut into the same length and we end up using all the string? So let's see, 64, let's find that GCF, would be 8 times 8. And then 8 is 2 times 4. 2's are prime, but the 4's would be 2 times 2, and one more 2 times 2. So let's see, 64 ends up being 2 to the 1, 2, 3, 4, 5, 6th power. So 1, 2, 3, 4, 5, 6. There's my prime factorization for 64. Now 56, how about 8 times 7? And then 8 would be 2 times 4, and 4 would be 2 times 2, and all of those 2's are prime. So we have 2 times 2 times 2 times 7. All right, so what do these two prime factorizations have in common? Well, it looks like it's 3 2's. We got 3 over here, we have 3 over here, and 64 has 3 more 2's, and 56 has 1 more 7, so nothing else in common. So what is 2 times 2 times 2? Well, 2 times 2 is 4, times 2 is 8. So it looks like 8 inches is the longest you can cut and have all the string end up being used. Hey, there we go, the end. Well, if you need to re-watch the video, go ahead and watch it as many times as you need to so you understand how to find the greatest common factor, or do a search on YouTube and type in greatest common factor. Maybe someone else has a video that you could watch. Check out the questions on my webpage, and we'll see you tomorrow. Please hit submit once you finish all those questions so that I can grade your homework. Thanks, guys. Thanks for joining me as we work our way through the 7th grade Math Connects textbook. Feel free to email me with any questions. My website is www.mattzigner.com. On my site, you'll find links to my math blog, some of my favorite educational sites, and lots of helpful information for students, parents, and teachers. See you next time.